What's up everyone, Patrick here, welcome back. And in this next video, what we're gonna do is get some practice in taking all these expressions, notice there's 8 of them, and rationalizing the denominator. So basically what we're gonna have to do is notice that all these denominators, they have these radical terms, and we're gonna have to work on getting rid of them. So lots of different scenarios here, lots of different simplifications that are gonna go on. And so I feel like this is going to be great practice. What I actually recommend doing is as I go through these, maybe pause the video, try number 1 yourself, see what you get, then watch the solution. And then pause it, try number 2, watch the solution. Maybe don't do them all at once. So pausing it at the beginning and trying them all at once, because there may be some mistakes you make that carry over. So you want to catch the mistake as you progress through the questions, and it's also going to help in not making that mistake a habit with repetition, right? So I actually recommend trying these one at a time, watching the solution, pausing it. Or if you just want to watch it, you can do that too, but you're going to get more out of it if you try it yourself. So I'm going to erase these for now. I'll bring them back later on in the video just to give myself room to work here. So the first one, we got 5 root 5 over root 6. So we're trying to get rid of this root 6. Now what we want to do is first look if we can simplify any radicals in the initial expression that we're given. Notice root 5 we can simplify. Root 6 we can't simplify, but you're going to see as we go through the examples, you're going to be able to simplify initially, like this root 8, for example. And I always recommend taking that route. It's going to save you work in the long run. But we can't simplify anything here, so we can go straight into rationalizing. So we would multiply this by root 6 over root 6 to get rid of that, right? So it's like we're taking this, multiplying it by 1. So this would end up being 5 root, what's 5 times 6? 30. And then root 6 times root 6 would give us 6, like that. And then what you want to do is you want to see, can you simplify this? Notice 5 over 6 doesn't simplify. And then the root 30, that doesn't simplify either, because if we try to break it down, like 2 times 15, we can do 10 times 3, we can do 6 times 5, which we already know these two don't simplify as we mentioned, right? No matter which way you break down 30, none of these numbers are going to be rootable. They're not going to give you an integer, okay? So root 2, root 10, root 3, root 15, those aren't rootable numbers, and so you actually can simplify root 30. So this here ends up being the final answer for number 1. Now number 2, we got 2 root 8 over root 3. So as I mentioned, you want to check first, at least that's what I do, is can you simplify any of the radicals at this step here? And the root 8, we can simplify that. We could break that down into root 4 times root 2, and that would be 2 root 2. So we could rewrite this as 2 times 2 root 2, and that's going to be all over root 3. And this would end up being just 2 times 2 is 4, so we'd have 4 root 2 over root 3. And now we could simplify this. Now if you didn't do that, like if you kept the 2 root 8 over root 3 and then you multiplied it by root 3 over root 3, you can do that too if you want. But then what's going to happen is you're going to have to end up simplifying that root 24 at the end. And this is going to be a bigger number than the root 8, right? Because if this is a multiple choice question, highly doubt that they're going to leave it as root 24. They may, but they're probably going to simplify it. And then root 24, it's going to be more work to simplify than root 8. So again, in my opinion, I feel like it's better to simplify initially, take the time to, before then rationalizing. And then from here, you can rationalize that root 3. So we'd multiply this by root 3 over root 3. So this would end up being 4 root 6 over 3. The root 6 doesn't simplify, and then 4 over 3 doesn't simplify. So that would end up being the final answer. Another thing I want to mention is these you could check your answers too. If you have a calculator, you could plug this in, get the decimal value, and then plug this in, 4 root 6 over 3, get the decimal value, and the decimals should be the same. Right? Notice how for both of these, there's no more radicals in the denominator. Moving on to number 3, we got 4 over 5 plus root 5. So notice we have a 2-term radical here that we have to rationalize. So the way we would do that, well, first off, can we simplify this any further? No, we can't. The root 5 doesn't simplify. There's nothing we could factor out from both of these here. The 5 is common, but the 5 is inside the radical, while over here there's no radical. Right? If there's a 5 on the outside here, then we could take out the 5, see if maybe the 4 over 5 simplify, which it wouldn't, but sometimes it will. But in this case, you just can't simplify this any further. So what we got to do, we got to multiply this by the conjugate because it's a 2-term, so we'd have to multiply this by 5 minus root 5. 5 minus root 5, like that. We're just changing that sign in the middle. And what that allows us to do is the numerator, let's keep those 2 terms separate for now. But then over here, because we're multiplying this by the conjugate, as we've shown in previous videos, we just have to multiply the ends, right? So 5 times 5 would give us 25. This is always going to be a minus, and then root 5 times root 5 would give us a 5, like that. And so from here, we would end up with 4 times 5 minus root 5 all over 20, like that. And then notice the 4 over the 20 simplifies. That simplifies to 1 over 5, right? 4 over 20, divide this by 4, divide that by 4, that would simplify to 1 over 5. So this would end up being 5 minus root 5 all over 5, because there's like a 1 in front here, so multiplying it by this bracket, we just end up with 5 minus root 5. So that's the final answer for number 3, right? And this here does not simplify any further. And again, you could check your answer, take this decimal, take that decimal, they should be the same. And then number 4, this one's interesting because we're going to be working with only variables. Right? There's no numbers here. Same thing applies though. So can you simplify root AB, root A, root B? Those don't simplify, so we can go straight into rationalizing here. So we'd multiply by root A minus root B by the conjugate of the denominator. And so what would happen here, the top I'm actually just going to leave for now. Those 2 terms separated, but then this times this, we just have to multiply the ends. Root A times root A gives us A, root B times root B gives us B. Right? We only have to multiply the ends because technically we should be foiling these out, and we're actually going to FOIL this out in the numerator. But when you FOIL them out, because we're multiplying by the conjugate, those middle terms are going to net out to 0. So we're just going to be left with those 2 terms where the ends are multiplying. So we'd end up with A minus B in the denominator. Now from here, what you want to do is you can leave it like this, but what you want to do actually is you have to be careful. You have to expand this and see if it further simplifies. Because a lot of times you may get an answer like this, but there may be a more simplified answer, and you're going to see this actually does simplify. So there's going to be a further answer maybe on a multiple choice test, and you're going to think you got it wrong. You didn't get it wrong, you just didn't simplify further. So you got to make sure you do that. When you get something like this, expand it all and then see, does stuff cancel out? can stuff maybe factor out that's going to simplify with this? You got to make sure that it's fully simplified. So root a times a, that would just be a root a. Root a times root ab, that would give us, a times ab would give us a squared b. Like that, right? Two radicals multiplied by each other, we could take the terms under the radical, multiply them by each other. And then same thing, we'd have minus root b times a, which would give us minus a root b. And then this minus root b times root ab would give us minus root ab squared, like that. Right? ab times b is ab squared. And then this is going to be all over a minus b still. Now from here, you want to simplify, and simplifying the numerator at this point, notice that there's no common radicals. At least it doesn't seem like that yet. We got root a squared b, root b, ab squared, a squared b, those are different. But the a squared b and then the ab squared, those actually simplify. So notice that this, for example, we could split this up into the square root of a squared and then the square root of b. Because these are multiplying, we can just split that radical up with both. What's the square root of a squared? That's just a. And then the root b we can simplify. And then notice that the square root of ab squared, same thing, root a times root b squared, which would be root a times b, which would be b root a. So this and this are the exact same thing, then this and this are the exact same thing. And now notice, stuff will simplify because we'd have a root a plus this a root b minus a root b minus b root a. And that's going to be all over a minus b, like that. So what's happening here? Notice those cancel out. And so we're left with a root a minus b root a all over a minus b. Notice what can we do? We can factor out a root a in the numerator, and we'd be left with a minus b all over a minus b. Notice those cancel out. And so we'd end up with root a, like that. And that's the final answer. A very simple answer. And you wouldn't think that you'd get to this from, for example, this point. But as you simplify the radicals, you do end up getting there. Right? So that ends up being the answer for number 4. So a great example of where in the middle of the question you may think you're done, won't simplify any further, but if you keep plugging away at it, you get a much simple answer at the end. Now moving on to number 5, we got negative 4 minus root 7 all over root 5 plus root 2. So from here, got to multiply this. Actually, first off, can you simplify any radicals? Root 7, root 5, root 2. None of those simplify. So we can go straight into rationalizing that denominator, multiplying by the conjugate here. Both the numerator by the conjugate and the denominator, just switch the sign here. So what would happen is we'd end up with negative 4 minus root 7 times root 5 minus root 2. I'm going to keep those separated for now. We are going to have to expand those. Then over here, root 5 plus root 2 times root 5 minus root 2, just multiply the ends. Root 5 times root 5 gives us 5. And then root 2 times root 2 just gives us 2, like that. So from here, what we do is we do have to FOIL out that numerator, right, to check if anything is going to simplify. So this times that would give us negative 4 root 5. This times that would give us minus root 35, right? 7 times 5 is 35, and they're both under the root, so we put this under the root. Then we would do minus 2 times negative 4, which would give us positive 8 No, it would give us positive 4 root 2, sorry. I almost screwed up there, right? The negative times negative gives us a positive, and then if we have 4 times root 2, you can't combine these because this is not under a radical, and there's like a 1 here, so 1 times 4 is 4. So we got 4 root 2. Right? So notice how I almost slipped up there. So you got to be really careful when you're doing these. And then negative times negative gives us a positive. Root 7 times root 2 would give us root 14. Can't simplify that any further. And then from here, this is going to be all over 5 minus 2, which would give us 3. And then from here, you want to see, can you simplify the numerator? So multiple things to check for. Number 1, is there any like terms? Root 5, root 35, root 2, root 14. No like terms there. Can't simplify anything. And then you want to check, can you simplify the radicals? Root 5, you can't simplify. Root 35, you can't simplify. You can't break down 35 into a rootable number multiplied by another number, multiplied by another integer at least. So that's not going to work out. Root 35 doesn't simplify. Root 2 doesn't simplify. And then root 14, like root 2 times root 7, none of those are rootable numbers there. So that doesn't simplify any further. And so as ugly as a final answer it is, this is the final answer. Okay, nothing simplifies here any further. Can't factor anything else, so sometimes you could maybe factor the coefficients out. If there's like a coefficient, we got a minus 4 here, minus 1, a 4, and then a 1. But you can't factor out anything from that. These two have a 4, but then these two have a 1, so 1 isn't a multiple of 4. So you can't factor. Sometimes you could factor out coefficients, and then that factor can simplify with the denominator, but that's not happening in this case, right? So this just ends up being the answer to number 6. So final answer can be in this format, but if they do want to test your algebra further, it would probably be in this format. This could be in different order, right? Like the root 14 can be at the beginning, maybe the 4 root 2 can be at the beginning to make like a positive coefficient in the front to make it look a little nicer. But either way, that's it right there. Now moving on to number 6, we got root 27 plus root 2 over root 12 minus root 2 here. So this is an example where the radicals initially are going to simplify. Notice that root 27, we can simplify that. We could break that down into root 9 times root 3, which would end up being 3 root 3. And then the root 12, that simplifies to root 4 times root 3, which would end up being 2 root 3, like that. Now again, you don't have to necessarily do this. At this point, if you do want to just get into the rationalizing, you could take it and multiply it by the conjugate like that. It's just, again, there's going to be more simplifying for you to do later on with this 12 times the 27. You're going to have to take that number and then simplify it. So again, just my suggestion, I recommend simplifying first. So root 27 simplifies to 3 root 3, and then we got the plus root 2, and then that's going to be all over 2 root 3 minus root 2. Notice the root 2's don't cancel out. And then I would rationalize from here. So multiplying this by 2 root 3 plus root 2 over 2 root 3 plus root 2, like that. So what would happen here is we'd have 3 root 3 plus root 2. I'm going to keep these separate for now, but we will have to FOIL them out. Over, we could just multiply the ends here. 2 root 3 times 2 root 3 would give us 4 times 3. Right? 2 root 3 times 2 root 3. Be careful here. 2 times 2 is 4. Root 3 times root 3 is 3. Minus root 2 times root 2 gives us 2. Like that. And so what would happen here is, yeah, we gotta FOIL out the numerator at this point. So 2 root 3 times 3 root 3 would give us 6 times 3. Be careful here, especially with mixed radicals like this, where you're multiplying the coefficients and then the terms under the radical, right? 2 times 3 is 6, root 3 times root 3 is 3. Then we got 2 root 3 times root 2. So there's like a 1 in front here. 1 times 2 is 2. Root 2 times root 3 is root 6. Then we'd have the root 2 multiplied by the 3 root 3. There's like a 1 here. 1 times 3 is 3. Root 2 times root 3 gives us root 6. And then we got root 2 times root 2, which would just give us 2, like that. Right, so when we FOIL it out, this is what we end up getting. This is going to be all over 4 times 3 is 12 minus 2 gives us 10, like that. And now from here, what would happen is, let me erase this. So I kind of space these out just so to have room for these. 6 times 3 is 18, plus 2 would give us 20. And then these are like terms, right? The root 6, the root 6. So 2 plus 3 gives us 5. So we end up with 5 root 6. This is all over 10, like that. Just give me a sec here. Let me make sure. Yeah, we're all good. And so we end up with 20 plus 5 root 6 all over 10. This simplifies further because notice that from both of these we can factor out a 5. Right? So this would end up being 4 plus root 6 all over 10. Right? Took out a 5 from both of these. When you're factoring from a radical term, you're factoring from the coefficients, not from the radical, that's staying. But it's like a 20 and a 5. Common factor between that is 5. We could take that out. So 20 divided by 5 is 4. 5 divided by 5 is just a 1. There's like a 1 left over here. If this was like 10 root 6, then there would be a 2 left over here. Right? But there's only a 1 there, so it's just root 6 all over 10. Now notice 5 over 10 simplifies to 1 over 2. So this would end up being 4 plus root 6 all over 2. So that ends up being the final answer for this. A pretty nice expression. You can't simplify this any further. This may be written another way, actually. This could maybe be like 4 over 2 plus root 6 over 2, which would be 2 plus root 6 over 2. The root 6 doesn't simplify any further. So this is maybe on a multiple choice test, another format. This could be in, this and this are the exact same thing. But whichever way you write it, those are the final answers for number 6. Now moving on to number 7, we have x minus y over the square root of x plus the square root of y. So notice here we can't really simplify anything, the square root of x, square root of y. So we could rationalize from here. So what we would do is we would multiply this by root x minus root y over root x minus root y. And what's going to happen here is these two terms I'm going to keep separate in the numerator for now. And then over here, what's going to happen is we multiply the ends because we're multiplying the conjugate. So root x times root x gives us x. And then we have plus minus. And then root y times root y would give us just y. And then if you notice from here, notice we have x minus y and x minus y. So these here would cancel out, and we'd just be left with root x minus root y. And then that doesn't simplify any further. So that there ends up being the final answer for number 7. And then finally, moving on to number 8, I feel like this one is going to be the most hectic one. This is going to be a good one because it's going to give us a lot of review in terms of simplifying radicals. So notice we have numbers mixed with variables in this one. and then plus the rationalizing. And it's not too bad because there's only one term here in the denominator to rationalize. This could have been a lot worse if there was two terms. There'd be a lot more expanding. But even like this, there's going to be a lot going on. So first thing I'm going to do here is I'm actually going to simplify all of the radicals first. You don't have to do that. You could rationalize from here. You can multiply that whole thing by root 18x over root 18x to get rid of that radical in the denominator. Is just after there's going to be a lot of simplification. So I'd rather simplify now, and then the simplification will be a lot more simple as the question goes on. So from here, we got root 20 x to the power of 5. So if you remember from videos before where we simplified radicals with a mix of numbers and variables, we could split this up like that. The root 20 would be what? Root 4 root 5, which would be 2 root 5. So that's what root 20 simplifies to. I'll put that in brackets. What about root x to the power of 5? So if you remember, what we want to do is we want to split up this x to the 5 in terms of x to the exponent of an integer that is less than or equal to 5 and a multiple of 2. Notice there's like an invisible 2 there because we're square rooting. So what are some multiples of 2? 2, 4, 6. So the highest one that is less than or equal to 5 would be 4. So what we want to do is split up that x to the 5 to be x to the 4 times x to the 1. And so from here, let me put this to the power of a half, and then each of these can go to the power of a half. And then 4 times a half gives us 2. This should always be an integer if you pick this number correctly. And then 1 times a half is a half. X to the half is the square root of x. Right? So this square root of x to the 5 simplifies to x squared root x. You may go about this in a different way. You may have your own process. Just make sure that you are getting that for the simplification of that radical right there. And so this here would end up being 2x squared, and then notice we can actually combine the 5 and the x like that under the radical, right? Root 5 times root x gives us root 5x. And so we took this and simplified it to this. Now again, you don't have to simplify at this step if you don't want, but just in my opinion, it's going to save you a lot of time. So notice that we have this 2 here. So we'll have 2. And then in square brackets, the root 20x to the 5 simplified to this. Like that. Right? And so now we can move to the next radical, which would be root 12x squared. So we'd have a minus, and then the root 12x squared, I'm going to simplify here, so that'd be root 12 times root x squared. The root 12, we can break that down into root 4 times root 3. And then the root x squared, that's just x, right? The square root of x squared, which is like x squared to the power of a half. Multiply those, it would be like x to the 1. The x would just be by itself. And then from here, we'd end up with 2 root 3x. And I'm actually going to put the x with the 2 just to separate the regular terms from the radical terms. Right? So the root 12x squared simplifies to 2x root 3. So we would end up with minus 2x root 3 over here. And then that's going to be all over the square root of 18x. What does this simplify to? Well, we have the square root of 18, square root of x. Square root of x, can't simplify that any further. Square root of 18, we'd have root 9 times root 2. And so that would be 3 root 2. And then we got the root x, and then we could combine these two. So 3 root 2x, right? So root 18x simplifies to 3 root 2x, like this. And now it's going to be a lot better to rationalize this, right? We had to do a little bit of work at the beginning, but it's going to save us work now when we get to rationalizing. Now, before getting into rationalizing, notice we can multiply these 2's here, so that would end up being 4x squared root 5x minus 2x root 3 over 3 root 2x. Now, actually, something I'm realizing here, whenever you get a chance to potentially factor the numerator, I actually highly recommend taking it. Notice from these two terms, we could take out a 2x. So we'd have a 2x, and then we'd end up with 2x root 5x, right? 4x squared divided by 2x ends up giving us 2x. Minus, we took out the 2x, so we're just left with a root 3 here. And this would be all over 3 root 2x. Now, in this case, this and this don't simplify, like the 2 over 3 don't simplify, and then this x, there's no like other x over here that would cancel out with this. So in this case, the factoring didn't really help us too much, but I recommend always taking the opportunity to see if it will, further simplify before getting into the rationalizing. Okay, in this case, it didn't simplify. But again, just be on the lookout for those opportunities. It's, again, going to save you more work in the future. But nothing simplifies here, so I'm actually just going to leave it like this, but just wanted to mention that you should be on the lookout for that. So from here, we can rationalize. And notice that we don't have to worry about this 3 here because there's no radical with this, so we only have to multiply this by root 2x over root 2x, because really we just have to get rid of this radical term. And so that's why this simplification before is making this easier, because instead of multiplying it by root 18x over root 18x, much larger number, we just have to multiply it by this smaller number here. And so what would happen is we would end up with, I'm going to keep these two terms separate. So the root 2x, let me put in front, and we'll still have the 4x squared root 5x minus 2x root 3. All over 3, and then root 2x times root 2x just gives us 2x, like that. And so from here, notice that we got rid of the radical in the denominator. It's just now we're going to have to simplify. So simplifying from here, what we would do is this root 2x, I'm actually going to distribute to both of these terms in the bracket. Now you got to be very careful, so I'm going to do the work on the side here. Root 2x times this whole term, 4x squared root 5x. If you're getting complex expressions like this, highly recommend doing the work on the side because it is easier to slip up here. So the root 2x, there's like a 1 in front. So the 1 times the 4x squared, we multiply the coefficients. That would just be 4x squared. And then the root 2x times the root 5x, what's 2x times 5x? That would give us 10x squared, like that. Right, so this times that would give us that. So that would be 4x squared root 10x squared minus, same thing, but now we're multiplying it by 2x root 3. So 2x times 1 gives us 2x. And then root 2x times root 3 would give us root 6x. Right? Yeah, looks good to me. So this times that gives us this. So this would be 2x root 6x. All over 3 times 2x gives us 6x, like that. Now, one thing, at this point, we're going to have to simplify this. I would look at the radicals. Notice we could factor out a 2x, and that's going to cancel out with this and simplify it. You can do that step first, but personally, at this point, I would first look at the radicals to simplify before doing that. So notice the root 10x squared we could split that up into root 10, root x squared. Now root 10, we can't simplify that. Can't break that down into a rootable number, but the root x squared, that's just x right there. So this root 10x squared is the same as root 10 times x. And so we would have 4x squared times root 10 times x minus 2x root 6x all over 6x. Right, so notice we were able to take this x out, and then x times the x squared would give us x cubed, and we just have a root 10 there, minus 2x root 6x all over 6x. Right, so you don't have to do it at this step, you could do it later, but I personally like to simplify the radicals first. Now the root 6x, you can't simplify that right there, right? Root 6 doesn't split up into a rootable number. And now from here I would factor. So notice from the 4x cubed and the 2x, remember we're always factoring from the coefficients in front of the radicals, not from these radicals. And notice these two radicals, they're not like terms. We have a root 10, root 6x, right? You can't just subtract these terms here, combine them. So from the coefficients, we could take out a 2x. And what would we be left with? So 4x cubed divided by 2x would give us 2x squared. And then we'd have the root 10 still. And then from the 2x, we took out the full 2x. So we're just left with the radical, the minus root 6x, like that. And that's going to be all over 6x. And then notice the x's cancel out. 2 over 6 simplifies to 1 over 3. And so we would end up with 1 times all of this is just that expression, like that, all over 3, and that is the final answer. That doesn't simplify any further. All right, so this here ends up being the final solution for that. All right, so as I mentioned, a lot of good practice with this one. First, we had to simplify the radicals. That was a process in itself. And then we rationalized it. But then with the rationalizing, there was a lot of algebra. There was a lot of more simplification. So just in case you run into something more complex, even if you don't, this is a pretty complex one. Just feel like it's good to go over this stuff and just so you know the different algebraic rules and the process to go through when you're getting these simplified terms.